So let's just think about where we're at right now. Well, you've done problems where there were negative coefficients, so you had to divide and deal with that. You've also had variables on both sides. But the whole point is they've all really been the same as what you've done in the past, just with inequalities now. So when I look at this, there's parentheses that are added on. So you're going to have to use the distributive property. Yeah, there's some times where it's better not to distribute, but for a lot of these, you will want to distribute. But there'll be one in here where we'll look ahead and decide whether or not that's the best decision. And then here, these have empty sets and all real, so that's something a little bit different, but the appearance of these problems is that they really are just the same as these guys. So we'll probably do 2 of each of these, and then the third one you can type into Wolfram Alpha or something, if you need to see if you're correct or not. So here's number 1, 3D minus 2 times the quantity, 8D minus 9. I'll close that parentheses. And then I'm going to make the the greater than symbol stand out slightly. And then over on the other side, I'll make this in blue. Negative 2D minus 4, just so this parts stand apart. So the first thing we're going to do is we're going to distribute. We're going to get rid of the parentheses, which will leave me with 3D on the left side, minus 16D plus 18 is greater than negative 2D minus 4. I look on the left side, and is there anything that can be combined? Well, these both have a D, and 3 minus 16 will give me negative 13D plus 18. And that's greater than negative 2D minus 4. I'll take 18 away from both sides. Doesn't really matter. I could have done the D's first. Usually I would. It gives me negative 13D is greater than negative 2D minus 22. Adding 2D to both sides gives me negative 11D is greater than negative 22. Divide both sides by negative means you have to change the direction of the sign, and I'm going to have D as less than positive 2. Now checking this is not an ugly fraction, so this might work out okay to where we can do this in our head. Let's try out 2. 3 times 2 is 6. 8 times 2 is 16, minus 9 is 7, times 2 is 14, so that's 6 minus 14 is negative 8. And then when I plug in 2 on the other side, it's going to be negative 8 as well. So that actually did work out nicely. We can also try an extreme value, like negative 1 billion. Or you know what, maybe just 0 would be easy too, because 0 is less than 2. This value drops out, this value drops out, so I have negative 2 times negative 18, positive 18. And then this term drops out, and 18 is greater than negative 4. So keep in mind, these are true statements. These inequalities give you true statements, so you can check anything within those sets of all those real numbers that exist. And that makes you pretty confident, pretty secure that you're, in the right ballpark at least, 6 times 5z minus 3. Well, remember how we distributed last time? Sometimes it's nice to avoid it. Is this whole right side able to be divided by 6? Well, I'm just going to put the whole thing over a fraction with the number 6. That means that this goes away, and I have a value of 6 here, and I'll get 5z minus 3 is less than or equal to 6z. I'll take 5z away from both sides, which gives me negative 3 is less than or equal to 1z. Or I can say z is greater than or equal to negative 3. Let's check this, and then I'll say one more thing about these two problems. So z is greater than negative 3. We can check that crossover point. I'm going to erase this so it's not cluttered. And I always talk through these checks quickly because I don't want to make you watch video after video of me just checking problems, but it's always something you want to do. This becomes negative 15 minus 3 is negative 18, so it's negative 18 times 6. And then this one's 36 times negative 3. And it's just going to be the same thing. Just type those suckers in. The other thing we can check would be 0, because 0 is greater than negative 3. This term would be dropping out. That would be negative 18. this would become 0, and negative 18 is less than or equal to 0. So we're good there. And you can also try out false values too, like if you wanted to try 0 even if it wasn't included. So in this first one, it was beneficial to get rid of the to distribute and get rid of those parentheses. Here, I actually think it was less work to do it ahead of time and just to avoid distributing. Now here, if you look at this one, I could divide that by 2, but that gives me a fraction. Or I could divide this by 3, negative, same deal. So clear those parentheses, distribute, and this will be an OYO problem, so pause the video and then check it using your thoughts, your calculator, and then lastly, Wolfram Alpha. A quick little refresher on the word set. Now this is going to be in red. But like sometimes you'll hear well, x is the set of all the numbers where x is greater than or equal to 0. So that would be like written in brackets. So that would tell me all the possible values that x can be. I could also list the values of x, as like 2, 4, 8, 10, just listing random values. But if that set of solutions is empty, it's kind of like saying there is no solution. So this is going to be like the no solution case, and then all reals is like anything will work. So we're looking at the unique cases of inequalities where it doesn't really matter what t is. Or maybe it really matters what t is and there's no possible value that exists. So here's 8 times t plus 2 minus 3 t minus 4 less than 5 t minus 7 plus 8. Okay, I'm scanning through that. That's a lengthy problem. I want to make sure I didn't rewrite it wrong. I'm good. Okay, so let's distribute. 8t plus 16 minus 3t plus 12 is less than 5t minus 35 plus 8. Try to keep your symbols more in line than mine. I'm just not really having that much space, and it's challenging to be more neat on an iPad. So I'm going to combine like terms on the left, and I'll have 5t plus 28. Pause the video at any point if you're not sure where those numbers came from. Is less than 5t minus 27. Yeah, I think that's good unless I made a mistake. Then we will try to get it to where we have t completely by itself. So I get 28 is less than negative 27. Now, just like we did earlier, this is a false statement. Because this is a false statement, this tells you there's no solution. This is an empty set. So I'm going to write it like that. So no matter what t is, it doesn't really matter. 28 is never going to be less than negative 27. Let's say we would have gotten a true statement. Then we could have said, well, it's all the real numbers, infinite solutions. So let's see what happens with problem 2. Now, these infinite and no solution type problems are really nice when you get home and use Wolfram Alpha, because these are usually a little bit more challenging to check because you can't plug in an actual value. (18 minus 3 times the quantity AC plus 4 is greater than or equal to negative 6 times 4C minus 1. I'm going to get rid of my parentheses. 18 minus 24C minus 12 is greater than or equal to negative 24C plus 6. Are you thinking something that I'm thinking? Well, yeah, just like the last one, it probably is going to match up. Now, we could just cross these out if we wanted to, but I'm going to simplify first. Negative 24C plus 6 is greater than or equal to negative 24C plus 6. If you feel comfortable, cross it out. If not, let's add 24C to both sides. And then I'll get 6 is greater than or equal to 6. Well, that's an or statement. It's not like it has to be and. Well, 6 can be equal to 6. We're good here. So this would get the smiley face condition. So this would be x is a double struck r. That means it's all the real numbers. If you don't like that, you can write out x is all the real numbers. And if you wanted to, you could check a couple of these. You could plug in like 0 up here. You could plug in 10. You could plug in 100. You could like keep on plugging values in for forever. But that wouldn't be a surefire way of checking these, because these inequality problems don't just have one solution. They have many solutions. There are many different ways to communicate all the real numbers. You might also see Wolfram Alpha telling you infinite solutions. You might see something in the textbook at different points in time. So don't get stuck if you see something that doesn't look exactly like what you've seen before. Problem 3, make it an OYO and check it in Wolfram Alpha. So yeah, that's the empty set. Empty set meaning there's no solution, all the real numbers, where it can be anything. And that's usually where the variable disappears. And one last thing, do you see the 6 is greater than or equal to 6? You could subtract 6 from both sides if you wanted. And then you'd have 0 is greater than or equal to 0. And then you could add 5, and 5 is greater than or equal to 0. It doesn't really matter. Like, if you wanted to keep on taking this further, you could. But really, once you kind of have something that's the same on the left and the right, you know you're good. Here's the assignment. And I got a little comment here. I'm not interested in you worrying about justifying each step in the homework. So where the book tells you to do that, you can avoid that step.